Hi, Kelly. Sounds like you're having a little bit of troubles with this problem. This is number 12 from 6.2, where you're trying to solve this quadratic that has a trig piece in it, and it was not factorable, so I just kind of did the math real quick on quadratic formula to get it to where we have our decimals. And so then, so that's me just kind of plugging it into the calculator to get these decimals, and it sounded like you were good until you got to this point. So or just after this point. So I'm going to do the inverse sign to get this radian value and the inverse sign to get this radian value. And then we'll kind of talk about the fact that the sign that we get out of this is positive. So we got to look at the two different quadrants associated to that. And then we have a negative as well. So we're going to kind of put all this together. So, all right, so inverse sine of that value is 0.6950. 0.6950. Now, let me kind of take this to the next part of this is you had sine of some angle equaling a positive. Well, that's going to come from, and this is really kind of your reference angle. So that's going to come from these two quadrants. Okay, so this 0.6950 is actually the radian version of that. So 0.6950. So it's one of the answers. But then you also have this is 0.6950, this value. So to find this angle, I have to take pi minus this. So it's just like if we knew this reference angle was 20 degrees, we would take 180 minus 20. Well, we know that this is pi, and I'm going to subtract back the radian. So this angle is going to be pi minus 0.6950. Okay, I couldn't tell you what that is, so I need to let the calculator do this for me. So that minus 0.6950. Okay, so that value is 2.4466. Okay, this one is 0.6950. So that's one angle, that's a second angle. Okay, then we're going to go do the same thing over here, but it's going to be a negative. So our angles are going to be in those quadrants. Okay, so since we're doing inverse sine, it's probably going to give me a negative value here. I'll just write the positive though on here. So we're doing inverse sine of, I think, that decimal. So that is, so the negative is the direction, but I just want the reference angle to it. So it's 0.4011. Okay, now that's this. Now again, if we knew that was 20 degrees, I would take 360 and back it off 20 degrees. So I'm going to take 2 pi and back it off 0.4011. Okay, so again, I'll let the calculator do that. So I have 2 pi minus 0.4011. Okay, so that angle all the way around to there is 5.8821. Okay, so that's that one. And then 5.8821 to get to this angle right there, we are going to, again, I'll use a degree measurement just to make it easier. If we knew this was 20 degrees, we would add 20 degrees to 180. So we're going to add 0.4011 to pi plus 0.4011. No idea what that is. So pi plus 0.4011. So this value is 3.5427. Okay, so there are our other angles. So those are our 4 angles. And because they don't give you a range, they don't say that your angles need to be between 0 and 2 pi or 0 and 6.28. They want you to generalize the infinite amount of solutions. So basically, it repeats itself every 2 pi. So you'd have this angle, this angle, this angle, and this angle all plus 2 pi. Right, where n, no, it's those 4 angles plus 2 pi n. So n number of 2 pi's, and we're talking about where n is an integer. Okay, so it would be those 4, and each one of them would have the plus 2 pi, which ended up being your d value in the end. So hopefully that's helpful. It's just weird because it's not in pi, like a pi over 3 or pi over 6, excuse me, pi over 6 or something like that. But try to make it a degree measurement and see if what you would do with the degree measurement is going to be the same math here. So like same thing. You would have backed it off so many degrees, so it would have been 180 minus whatever it is. So instead it's pi minus whatever the reference angle is. And then over here we'd be tacking on. So it's going to be pi plus whatever the reference angle is. Here we're going to take 360, which is 2 pi, and we're going to back it off. So we're going to subtract whatever the reference angle is. Okay, so think of it sometimes as degree values, and then it might end up helping you with a little bit more of the complicated versions because the math is the same, the concept's the same. It's just more challenging because of the numbers. Hopefully that's helpful, and we'll see.